Hello mates. If you're following this as a series, you realize that we've just finished our coordinate systems. So let's tick that off. Now we are going to go into measures of time. So without wasting time, let's get into the measures of time. Okay. The first thing that we are going to do in the different measures of time, we're going to discuss something called sidereal time. That is the first topic we're going to look at. Sidereal time. Some people call it sidereal, some people call it sidereal. For me, I usually call it sidereal because that is easier on my tongue. Sidereal time, but you can call it sidereal time. Depends on the pronunciation that you want to use. So yeah, okay. This is what we are going to do. What we are going to do. If you remember from our previous videos, when we were talking about the Earth rotating, and then when the Earth rotates, the celestial sphere tends to rotate in the opposite direction. If you remember what I tried to describe when it started on the celestial sphere, the video about the celestial sphere. If you don't remember, you can go to the video about celestial sphere. If I remember well, I discussed that that when the Earth is rotating in this fashion, the celestial sphere, of course, it's fixed like this. But when you're on Earth, when you're rotating like this, the celestial sphere appears to be rotating in the other way. So now, the Earth rotates uniformly about its axis relative to the fixed stars, isn't it? The stars will be fixed. We have the Earth here, and the stars will be fixed. As it is rotating, the stars that are on the celestial sphere appear to be rotating uniformly about the celestial sphere axis in the opposite direction, like this. Imagine this is Earth. If that is Earth, and this is our nice Africa. Oh, today I written nicely today. If this is our Africa, imagine there is a star here. As the Earth rotates like this, you know the Earth rotates from west to east, like this. This star here, as I'm seeing it like this, as I'm curving like this, it appears as if I'm stationary, but the star is the one that is coming like this. If the Earth rotates like this, this star, imagine I'm stationary, the star will appear to be going in this direction. So the sky, the celestial sphere, rotates from east to west like that. So it also rotates on the axis. The Earth rotates on its fixed axis, isn't the one that connects the north geographical pole and the south geographical pole. So the celestial sphere rotates about the same axis that connects the north celestial pole and the south celestial pole, like that. So that is one point to note, that it rotates from. That is one point to remember, because we noted it before. That the celestial sphere rotates from east to west. So now we consider the interval between successive upper transits of a star. If you remember what upper transit is. Upper transit. I hope you remember what upper transit is. If not, just go back to the video that's written. I think I think it talks about right ascension, declination, and upper transit. Just go back to that video and you learn about, or you recall what upper transit is. Upper transit is when star is crossing observer celestial meridian. Observer celestial meridian. Just a quick recap. Imagine I'm not going to draw Earth. I'm just going to put a dot there. Imagine that is Earth, and this is our south celestial pole. Okay, imagine this is the what? Celestial sphere, or that is the observer celestial meridian. If this is the south celestial pole, this being the north celestial pole, we have a celestial axis that cuts through Earth and then goes to the north celestial pole. Perpendicular to that, we have our celestial sphere that goes like this and then goes at the back like that. And if you remember, well, our stars, they move in paths that are parallel to the celestial sphere. So a star will move in a path that is parallel like this. That would be the path of the star. So imagine a star that moves in this path here, in a path like this. When the star is crossing the observer celestial meridian at that point, we are calling it the upper transit point. Okay, some people might argue that it's also crossing at this point, which is also true. But the upper transit occurs when the star is when it's crossing above the what? When it's crossing the celestial meridian above the visible pole. That's when upper transit occurs. So there are two. Let's just go. There are two transits. The one with transit as in it's when something is in transit, it's passing something, or we can say it's passing something. It's in this case the transit is referring to what? The observer celestial meridian, this one here. So we have two transits. This when it's passing the celestial meridian at this point, and also this one it's passing the celestial meridian at that point. So now we now decide which one is going to be upper transit. Upper transit is going to be the point where it's crossing when it's above the what? The visible pole. If this was the North Celestial pole, it doesn't matter what pole it is, as long as the point is above the visible pole. Because the two transits will be on opposite sides of the visible pole. It's on this side and this side. So which one is the upper transit? Is the one that is above the visible pole. So this one is going to be our upper transit. So now the period between successive upper transit of a fixed star is equal to the period of Earth's rotation, and it's called a sidereal day. Sidereal day. So now this point says the period that is between the star being here, as you can see, the star is there, right? So as the Earth rotates, this star will let me say move, but obviously the star will not move in that fashion, but because of the Earth's rotation it appears as if the star is moving. So let me just say the star is moving. So as the Earth rotates, the star moves maybe to this point, and then it will be at this point, and then at this point, as the Earth is rotating, this point, it reaches this point now called lower transit. This is upper transit, this one is lower transit. It reaches lower transit, the Earth keeps rotating, then the star it keeps moving along its path like that, and then it comes back to upper transit. So it was at upper transit, the Earth rotated, and then it went back to upper transit. So that period between two successive upper transits is called the sidereal day. Sidereal day. So this is the period between two successive upper transits of a star. So sidereal day, let me just loosely say, sidereal day is not exactly fixed like our normal day. Our normal day, we know that it starts at 12 midnight. There's a system that we are going to fix sidereal day, but loosely speaking, sidereal day is not just like a normal day. We can say, okay, I want my days to start at 9 a.m. If you want your days to start at 9 a.m., tomorrow morning at 9 a.m., that is a complete day. You understand what? That is a complete day from 9 a.m. or let me see, the time right now is 2:57 p.m. So 2:57 p.m. 2:57 p.m. today is a Saturday to 2:57 p.m. tomorrow on Sunday. The period between these two is a normal day. A normal day that we talk about. A normal day that we talk about. So the day between the period between upper transit, two successive upper transits, when the star goes down and then comes back up to upper transit, is called a sidereal day. It's a sidereal day because we are talking about stars. We are going to see that maybe later on as we start discussing exactly what sidereal time is. So for now, we have now defined our sidereal day. A sidereal day is divided into 24 sidereal hours, and of which each one is what? So we have 24 hours making up what? One sidereal day. And these are not 24 normal hours that you see on your clock. No, these are not normal hours you see on your clock. These are 24 sidereal hours. I should have put sidereal here. We are going to see the differences later on, but these are 24 sidereal hours that are a bit different from our normal clock hours, the ones that you see on your phone or on your watch or whatever you use to check time. So these 24 sidereal hours make up one sidereal day, and 60 sidereal minutes they make up one sidereal. And I emphasize, this is not just one normal hour, a one sidereal hour, not one normal hour. So sidereal minutes, they make up sidereal hour. Just like that, going forward, 60 sidereal seconds make up one sidereal minute. So now, the sidereal day is taken to begin. Now we need to define when the sidereal day. I think I should state that for us not to be confused, just like for a normal day, someone could have said, no, I want my day to start at 12 p.m. Someone would have said, I want my day to start at 2 p.m. Someone would have said, no, I want my day to start at 6 a.m. So for us to have a convention, a convention should apply worldwide, right? We agreed that normal days that we talk about, days start at 12 midnight. That's what we agreed. We agreed that days start at 12 midnight, running to the next midnight. That is what a normal day. So for sidereal time, for us to talk about sidereal time, we need sort of like a convention. We need to know when sidereal time starts as well. When is the sidereal time going to start? If you remember, in our videos for ecliptic, we defined something called the point. We discussed something called point of. I think this was the spelling, point of Aries, like this, and we represented it with a letter, the Greek letter that looks like a V, like this. So this V, as we're discussing the origins of this V, we saw that it is a point where the ecliptic or the sun's path, where the ecliptic cuts the celestial equator. At that point, when the sun is moving from the southern to the northern hemisphere, we call that point the first point of Aries. And we said as the celestial sphere is rotating, this point also rotates with the celestial sphere. So it's a fixed point on the celestial sphere. It doesn't stay behind. It's fixed on the celestial sphere. So that is a good point to call that is a good point to reference, because it's fixed to the celestial sphere, and we can calculate where that point is, because we know when the sun is going to move from where the sun is going to move from the southern to the northern hemisphere. We know when that is, March 21. So before we get into when that happens, let's define our sidereal. Our sidereal clock, our sidereal day is taken to begin when this point V is in upper transit. So when this point V is in upper transit, that's when we define our sidereal day. Let's draw what we mean here. I'm going to draw maybe two diagrams. So this is the what? Let's call this the north celestial sphere, not celestial pole, and then this one I'm going to call the south celestial pole. So we are going to have our celestial axis. Our Earth is going to be here, so this is going to be our celestial equator. It is something like this. And then we have something called the ecliptic. We have an ecliptic like this. The ecliptic is the path of the sun, right? The ecliptic is the path of the sun like that. And where they meet, when the sun is crossing from west to north, we are going to call it what? We are going to call it the south. We are going to call it the. Actually, I should have put the south celestial pole here, because V would have, with this orientation, V will be the one at the back. But I'm going to put south celestial pole here and the north celestial pole here, because I want my sun, as it is moving from the south celestial pole, to move like this. The sun is moving from the south celestial pole into the not south celestial pole. I don't know what's wrong with me today. From the south celestial sphere to the from the southern hemisphere to the northern hemisphere. I want this point here to be called V. So this is the south celestial pole. This is the north celestial pole, like that. So this point V, we said as the Earth is rotating, it's a fixed point on the what? It's a fixed point because these two here, they meet only at 2 points, this point and this point, and the sun only crosses once from the south to the north. It only crosses once from the south to the north, and it's at this particular point. So this point is fixed on the what? On the celestial sphere. So as the celestial sphere is rotating, this point rotates with the celestial sphere, as we discussed when we were talking about right ascension. Okay, so well and fine. Since now this rotates with the celestial sphere, it means it will also go on into upper transit, because it's a point on the it's this point, right? So when it rotates like this, so when let me quickly draw another diagram. South celestial pole, north celestial pole. Okay, let's see if I can draw this the way I really want to show it. This is going to be the Earth, or the center of that sphere. Yes. Okay. I hope I've drawn that in a way that is not confusing. So can you see this celestial sphere is going to rotate, and then as it rotates, this point here that is fixed on the celestial sphere will also, imagine where my thumbs are meeting, that is the V. As the celestial sphere is rotating, V is also rotating with what? With the celestial sphere, because it's a special point. It is fixed. It's a special point. It's a fixed point on the celestial sphere. So it rotates as the celestial sphere is rotating. That is what is happening here. So it means this V is going to reach upper transit as well, because it's going to cut the celestial. It's going to cut the celestial meridian. It's going to be in transit. So when V is now in upper transit, let's imagine that V is now up there on the celestial meridian. That is when the sidereal day starts. Those who measure sidereal day will say, oh, where is V? Or V is almost at upper transit. So get our clocks ready. We'll get our clocks ready. When V just touches what? Upper transit, when it's crossing what? The celestial meridian, then we start our clocks and say the sidereal day has started. So sidereal day, sidereal, I don't know. Sidereal day starts when what? When V is in upper transit. That's when sidereal day starts, when V is in upper transit. So a sidereal clock is one which indicates the passage of 24 sidereal hours. When 24 sidereal hours, then when 24 sidereal hours pass, then a sidereal day would have what? Would have passed. So we expect our V to be back in upper transit, because what? One sidereal day has passed. So this was a video to define our sidereal day and our sidereal clock. In the next video, we are going to get into a bit of calculation of how to see this sidereal time being applied. So stay tuned for that video.